Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video. And today's video is about another interesting topic in 8086 microprocessor. We're going to see pin diagram of 8086 microprocessor. Right, in this video we will see in detail about the 40 pin diagram of 8086 microprocessor. Right, so this is the pin diagram of 8086 where we have already seen the basic features of 8086 and we have also seen the register organization of 8086, right? And in this video we're going to see only the pin diagram. I'll explain in detail about each and every pin. And we know that 8086 is a 40 pin IC, 40 pin microprocessor, right? And I have already said in features where it has two ground pins, right? You can see two ground pins, and these two ground pins specifically we have an 8086 to reduce the power dissipation, right? And apart from that, very important feature of 8086 is it supports minimum mode and as well as maximum mode, right? So we will start with the pin diagram explanation. I've already said about minimum mode and maximum mode, where in minimum mode this 8086 processor will be acting as a single processor. It will be acting as a single processor, whereas in maximum mode, what it will happen in maximum mode, it will be acting as a co-processor. That is, it will be working in a multi-processor environment. That is the basic difference between minimum mode and maximum mode. Okay, right? Now, when microprocessor will act as in minimum mode and when it will act as a maximum mode, we know that most of this IC, most of this pin supports dual purpose. You can see here these pins from 24 to 31, right? It has dual purpose. It has dual purpose here, right? That is, this supports minimum mode and this supports maximum mode, right? And when the 8086 will act as a minimum mode and when it will act as maximum mode, it will be decided by this particular pin number 33, where you can see min max, right? And here, whenever this particular pin, right, whenever this particular pin is connected to VCC, that is the power supply, right, the VCC, then this microprocessor 8086 will work in minimum mode. It will work in minimum mode. And whenever it is connected to ground, right, when it is connected to ground, it will work as a maximum mode. It will work as a maximum mode. And in minimum mode, it will act as a single processor, whereas in maximum mode, it will act as a co-processor. That is, it will work in a multi-processor environment, right? That is the very first thing you have to explain in this pin diagram. And apart from that, we know that it has 16-bit data bus. As I said, it has 16-bit data lines, 16-bit data lines, and 20-bit address lines, 20-bit address lines, right? You can see here from 16, A80 to 814, right? That is from 2 to 16. And similarly, this is called as address data lines, where it is from 0 to 15, like you can see here the 39th pin, right? So AD0 to AD15, so which means AD0 to AD15, so we'll have 16 address data lines, right? What is address data lines? As I said, you have 16 data lines, and in 8086 you have 20-bit address lines. You can see here this data line, that is 0 to 16, you'll have 16 data lines, right? And for address lines, you'll have 16. 0 to 15 is 16, and then you can see here pin number 16, 17, 18, and 19. That is A16, A17, A19, A18, and A19. Where these four pins, so totally 20 address lines will be there, right? So 8086 supports 60 data lines and 20 address lines. And this address lines will be multiplexed, time multiplexed with the data lines here, and it will be multiplexed with the status lines here, right? And we have a very important pin which is ALE. This pin ALE, right? This pin, what it will do is it will demultiplex this address line, data line, and status line, right? So whenever the ALE is equal to 1, whenever the ALE is equal to 1, right? So this AD line, the address, the AD line will be acting as an address line, and whenever it is equal to 0, it will be acting as a data line. Understand very clearly. Whenever the ALE is equal to 1, right, this multiplexed will be demultiplexed line, right? It will be demultiplexed and it will be acting as an address line, right? If the ALE is equal to 1, and if the ALE is equal to 0, it will be demultiplexed and it will be acting as only data line. Similarly, coming to here, whenever ALE is equal to 1, whenever ALE is equal to 1, it will act as an address line. These 4 pins will act as an address line, right? And whenever ALE is equal to 0, then all this pin will act as a status line, right? I'll clear all these things so that you can understand very clearly, right? So far what we have seen is we have seen what is address line, what is data line, how it is multiplexed and how it is demultiplexed, right? And we have seen what is minimum mode and what is maximum mode, right? And very importantly, the next important thing is BHE, right? So this particular pin, what it will do is it will enable the higher end data, that is from D8 to D15. High data enable. Whenever there is a high data enable, that will be indicated by this particular pin BHE, right? And similarly, we have a read and as well as write. Right, whenever we want to read an instruction from the memory, right? So this particular pin, right? Whenever this goes low, right? Whenever we want to set a pin, it will be equal to 1. But here, most of the pins like will be having a bar at the top. So RD is equal to 0. If RD is equal to 0, it will be active. If it is equal to 1, then it will be in lower state. Okay. So if RD is equal to 0, then we can able to read an information from the memory. Similarly, for write, whenever WR is equal to 0, we can able to write an information in the memory, right? And this MIO, it tells you which memory is accessed, right? If it is 1, then we access the normal memory, and if it is 0, then we will access the IO memory, right? And what is this DT? We will see all this pin in detail. I'll just say what is what here, right? DT is nothing but DTR is nothing but data transmit and receive. It tells you in which direction the data is getting transferred. If it is equal to 1, right, the data is transferred from the microprocessor to the external device. And if it is equal to 0, then data coming from other device to the microprocessor, right? And whether the data is there or not, right? Before transfer, data is there or not, that is data enable, DEN, something data enable pin which tells you whether there is a data or not. I already explained what is ALE, right? And similarly, you can see here, I'll come to this INTA pin, but before that we have to see these two interrupts. These two interrupts are non-maskable interrupts. NMI is nothing but non-maskable interrupt. That is the higher order interrupt in 8086. We already seen what is interrupt, what are the different functions of interrupt, everything in detail in previous videos. Please go through it, okay? But in 8086, non-maskable interrupt is the highest priority interrupt, and it will not be disabled by the software, right? So this is NMI, and the other interrupt is the normal interrupt INTR pin, which will be enabled by the IF flag, that is interrupt flag. Whenever IF flag is equal to 1, then interrupt flag will be 1, right? That is only when the INTR flag is equal to 1, the interrupt will be served, right? So if IF flag is not enabled, if IF flag is equal to 0, but there is interrupt INTR is equal to 1, then that interrupt will not be served, right? So non-maskable interrupt and INTR interrupt is two interrupts in 8086, right? And we have clock signal for internal timing operation, and we have different versions of clock signal where 8 megahertz, 10 megahertz, clock signals can be used, right? And I already said we have 2 ground pins to reduce the power dissipation, right? And apart from it, we come back to this particular reset pin. What is reset pin? Reset pin, it will completely reset the 8086 and it will start the execution from the first register, that is FFF0H, right, from that particular address, and it will make all the registers to start from the very first location, right? That is complete reset. But here, not to reset the microprocessor, right, this signal has to be enabled for at least 4 clock cycles, 4 mission cycles, okay? Only then the microprocessor will go to the reset mode, right? And this ready signal is nothing but whenever we want to connect an external peripheral device, microprocessor will work in a greater speed, right? But the peripheral device which we connect might be slower, right? So whenever this is equal to 1, right, then there is no change, the normal operation will be going on, and whenever there is 0, right, the microprocessor will go to the wait state so that it will be synchronized with the peripheral device. Similarly, this test signal is also for the same purpose, but the microprocessor will go to the wait state whenever it is executing the internal program, right? And that case, if you want to go to the wait state, then this particular signal will be enabled. And INTA is nothing but whenever there is an interrupt, right? Whenever there is an interrupt, it will be acknowledged. Whenever there is a device which is asking, it's enabling the interrupt, right? And that interrupt will be served or not, right? There is an interrupt that will be intimated by this particular pin INTA, right? And similarly, what is hold and hold DA? Hold is nothing but whenever a device want to access the system bus of microprocessor, right, it can give a request through this hold pin, right? And whenever there is a request, right, that will be acknowledged in this particular HLDA pin, right? So if there is request, it will be enabled. If there is no request, then this pin will be a 0, right? So I've just given you the overview of the pin diagram.
Thank you students, thank you for watching. கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும் நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.